Hello student, here is a question which says a uniform rod of mass m1. This is a rod, okay, this one is the rod and its mass is m1. Now it is hinged at its upper end. It is hinged at this point. A particle of mass m2, this one is a particle of mass m2 which is moving horizontally. This particle is moving horizontally like this, okay, and it strikes the rod elastically at its midpoint. If the particle comes to rest after collision, then value of m1 upon m2 is, we have to calculate the ratio of the masses m1 and m2, okay. So we will use the concept of conservation of angular momentum, okay. So we will use conservation of angular momentum, conservation of angular momentum, okay. So the conservation of angular momentum says that if the net external torque acting on any system is zero, then the initial angular momentum is equal to final angular momentum, okay. So we will take the hinge as the point of rotation, okay. So the net external torque will be zero, net external torque is zero. So the total initial angular momentum must be equal to the total final angular momentum. So initially the angular momentum is only for the particle which is moving with a velocity or speed v. So L initial is only for the particle and it will be mvr. So m into v into r. R is the point of collision. So this is the point of collision, midpoint. So this one is L by 2. So mv into L by 2. This is the initial momentum. Okay. Now we will calculate the value of the final momentum, and final momentum is only for the rod because the ball comes to rest after collision. So the ball makes a rotation, so the angular momentum of the rod will be I omega. So I into omega, and we know that the I is taken along the axis of rotation. So this is the point of axis of rotation. So I will be ml square upon 3, ml square upon 3, about that point. And what is omega? So omega is equal to v upon r, because v equal to omega r. So v upon r. So what is v? V is the velocity of the center of mass of the rod, and r is the distance from the axis of rotation. So velocity, for calculating VCM, we will use the velocity of separation upon velocity of approach equal to coefficient of restitution, this formula. So velocity of separation is velocity of center of mass of the rod divided by what is velocity of approach. So this particle is approaching with velocity v and e is equal to 1. So you can say that the velocity of center of mass of the rod is also v. So omega is v into L by 2. So so omega is v upon L by 2. Okay, so now we will put the values here. So I is m L square upon 3 into omega is 2v upon L. Now we will equate the initial and final angular momentum. So m2 into v into L by 2 is equal to m1 into, cancelling this L with this, m1 into L into 2v upon 3. Okay. So now this L is also cancelled out, this v is also cancelled out. So we have to calculate m1 upon m2. So m1 upon m2 is equals to 3 upon 4. Okay, this will be equal to 0.75. So the ratio of m1 upon m2 is 0.75. I hope that this is our answer. I hope that this cleared it out. Thank you.